हेलो एवरीवन, आज हम लोग पोटेंशियल और पोटेंशियल डिफरेंस के बीच में डिफरेंस पता करना चाहते हैं बेसिकली कि व्हाट इज़ पोटेंशियल एंड व्हाट इज़ पोटेंशियल डिफरेंस। ये टर्मिनोलॉजी आपको बहुत सारी जगह आती है, ग्रेविटेशनल फील्ड में भी आ सकती है, मैग्नेटिक फील्ड के अंदर भी आ सकती है और इलेक्ट्रोस्टैटिक्स में भी ये प्रॉब्लम आती है जब आप पोटेंशियल और पोटेंशियल डिफरेंस पता करना चाहते हो। तो आज हम लोग डिराइव भी करेंगे और साथ में एक कंक्लूजन निकालेंगे कि व्हाट इज़ द बेसिक डिफरेंस बिटवीन पोटेंशियल एंड पोटेंशियल डिफरेंस। तो हम लोग एक स्टेप वाइज चलते हैं और 1 से लेकर के n तक चलेंगे और जब n तक पहुंच जाएंगे तो कंक्लूड करेंगे सारी चीज़ों को। ठीक है, तो द बेसिक थिंग इज़ दैट कि वी हैव अ चार्ज कॉल्ड प्लस क्यू। ओके, अकॉर्डिंग टू न्यूटन he will convert into in mass and he will say that it is something mass of a charge and he can calculate potential energy from it according to Newton. But basically Faraday has derived, or you can say find out the field theory, यानी electric field at a distance। मतलब ये चार्ज यहाँ पे है, ये चार्ज यहाँ पे है, तो इन दोनों में क्या होता है, there is attraction or repulsion depend on sign, बट इन जनरल देर इज सम फोर्स। ये इस पे फोर्स लगाता है और इक्वली ये इस पे फोर्स लगाता है। तो अगर ये दोनों प्लस है तो ये इस पे इस डायरेक्शन में फोर्स लगाता है और ये इस पे इस डायरेक्शन में फोर्स लगाता है। और काम जो है हमें बहुत ही प्रोफेशनल तरीके से करना है फिजिक्स में, इसको वर्क करते हुए। यानी ऐसा नहीं करना है कि दोनों को एक साथ हम बात कर रहे हैं इस पे पहले सोचना है, पहले ये बॉडी लेना है एंड इनके बारे में बात करना है कि हेलो Q2 and hello Q1. So I will ask, hello Q1, how are you feeling? He will answer me that Q2 is basically opposing me with a force. Okay, I will write here Q2 as a reporter. I will write Q2 is opposing a force. So basically force on Q1 due to Q2. And I will ask him, Mr. Q2, how are you experiencing? So he will blame him that he is basically providing me, or he is pulling me out of this system, or there is a repulsion. So I will write as a reporter that there is a force on Q2 due to Q1. Okay, that is actually a Coulomb law in vector form. But what we are talking about here is Faraday tells that there is in between there is some field. There is a field. Okay, there is a field, and if you want to find out the electric field here, then you just have to do that electric field equals force experienced by any charge placed there. So if you place a charge Q2, then charge by experienced by Q2. What Q2 is experiencing here as a charge, he can tell electric field here. For example, the field line due to plus Q is always outward. Correct. This is the terminology we use in physics. So I want to find out what is the electric field here. Let us suppose that this is not a charge, this is a magnet, and you put a magnet here and you have an iron rod here. This is an iron rod, and if it is here and it is getting attracted, that means you can say that the field is up to here. This is what? This is a test magnetic, you can say test for a magnetic field. Okay, tester for magnetic field. And if you place this tester here, and you will see that the magnet is not basically providing a force here. So at this instant you can say that there is no field. So test charge actually acts as a tester. So I have a test charge, suppose Q0, and I want to find out the electric field at A. So I will ask Q0, hello Mr. Q0, how are you experiencing? So he will say that I am basically experience a force due to plus Q this way. Okay. In evaluating electric field, we don't consider that Q0 can apply a force on plus Q, because we consider Q0 to be very small. That is why we don't write like this. We just write like this and we say that force experienced by Q0 is electric field. And suppose you have you are having a distance at infinity, and you place a q naught here, and you want to find out the field at this point due to plus q. Then you place a test charge here, and the test charge will tell that there is nothing a field, there is no field there. I am not experiencing any force. If you will say I am not experiencing any force, then F is 0. He is not experiencing any force. Electric field will be 0. So that is how things go on. Now I want to find out, talk about potential. Okay. So what is the basic you can understand about potential? What is the most basic thing is that suppose q naught is at a distance d, and you have written electric field as basically force experienced by q naught. Then what is potential at point A? Then potential is denoted as V. Potential at A is dimensionally, basically you can actually write it this way: electric field, whatever electric field at point A multiplied by whatever distance d is actually a potential. So this is the very small definition or a very basic definition of potential. So from there, here you can find out that the E multiplied by R, and E is basically 1 upon R square, follow 1 upon R square, and this is also R. So R cancel out, so V will follow 1 upon R rule. So V must be proportional to 1 upon R, and electric field is proportional to 1 upon R square, and this is basically R, distance cancel out, therefore potential will follow 1 upon R. तो पोटेंशियल का जो बेसिकली फील्ड होगा वो कैसा होगा? अगर मैं इस तरीके का बनाता हूँ इलेक्ट्रिक फील्ड या पोटेंशियल, तो इलेक्ट्रिक फील्ड या पोटेंशियल विथ रिस्पेक्ट टू डिस्टेंस क्या होगा? तो अगर मैं 1 अपॉन आर स्क्वायर का ग्राफ बनाऊँ तो मुझे इतना पता है 1 अपॉन आर स्क्वायर, अगर मैं पुट करूँ 1 तो 1 अपॉन आर स्क्वायर विल गिव 1 अपॉन 2, इफ आई विल पुट 2 इट विल गिव 1 अपॉन 4, बट suppose 1 upon r square, so I will put 1, it will give me 1, I will put 2, it will give me 1 upon 4, I will put 3, it will give me 1 upon 9. Okay, 1 upon r, so it will give me 1 when I write r is 1, it will give me 1 upon 2 when r is 2, 1 upon 3 when r is 3. That means 1 upon r square is decreasing rapidly, but 1 upon r is decreasing but not that rapidly as 1 upon r square. So you can actually make a graph like this, okay, and this is suppose due to potential, which is 1 upon r, and this is electric field, that is 1 upon r square. As you can see, this is decreasing rapidly, so decreasing rapidly. Okay, these all things are basic terminology which you can understand from what is a potential or something like that. Okay, now basically जो potential और potential difference होता है, ये सब चीज़ आती है वर्क डन से. तो ये सब चीज़ क्या आती है? वर्क डन से. तो suppose I have a field, so suppose I have a plus q and I have a field due to plus q. It is coming outward, and in all the direction it will be coming outward, 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 outward. So field due to plus q is always outward. Okay. So suppose I have this point called A point, and I have this point called B point, and I have a test charge q naught, which is a positive test charge, and this is also positive. So positive will repel each other. That's a basic thing you can understand from Coulomb's law. Okay, what we are doing here is that till electric field and till Coulomb force, we have just stopped that charge at some point A, and I want to calculate here. So मैंने चार्ज को basically Coulomb's law और इलेक्ट्रिक फील्ड के लिए क्या किया? रोक दिया यहाँ पे एंड कैलकुलेट किया. बट यहाँ पे क्या करेंगे? लेट्स मूव, कुछ मॉडिफाई करते हैं. तो Q नॉट अगर मूव करता है A से B, सो Q नॉट ट्रेवल फ्रॉम A टू B. So what is the most important thing here is that q naught is traveling is not that much important. Q naught is traveling against this. It is actually repelling it. Plus q is repelling q naught, but still it want to come at B, so it came at B. So some work has to be done. You have done some external work. Some external work must be done to basically displace q naught from A to the B. तो टेस्ट चार्ज को आपने जो डिस्प्लेस किया अगेंस्ट दिस फील्ड, क्योंकि ये पॉजिटिव पॉजिटिव देयर इज अ रिपल्शन, एंड इस रिपल्शन के फील्ड में आपने ए से बी लेके आया क्यू नॉट को, दैट मीन्स यू हैव डन सम वर्क. ओके, तो सपोज यू हैव डिस्प्लेस्ड अ dx डिस्प्लेसमेंट, and the work done from A to B I want to find out. So basically from classical mechanics, small work done is equals to f dot dx. Okay, so dot product is there, that means there is f dx cos theta. So I will simply find out what is theta here. So A is dx is this way, dx is displacement is this way, and force are acting on A is this way. Force acting on A is this way. Okay, so that means force acting on q naught basically is this way. So force is this way and this. So the angle between force and dx is 180 degree. So cos 180 is -1. So you have dw work done is equals to minus f dx. So it is in magnitude. So you got this expression, and it is very important expression. Okay, so in इस equation को find out करने के बाद मुझे क्या पता चला? अच्छा, so I can find out work done because I have to find work done, क्योंकि यहाँ से यहाँ आने में कुछ वर्क लगा. वर्क डन मिल गया, यानी फोर्स F. व्हाट इज फोर्स हेयर? फोर्स अगेंस्ट व्हाट थिंग? तो अगेंस्ट दिस थिंग, दैट मीन्स देर इज सम कूलम फोर्स एट पॉइंट ए. ओके, तो एट कूलम फोर्स एट पॉइंट ए, सपोज आई वांट टू से दैट फ्रॉम दिस डिस्टेंस O to A, OA is x. Suppose OA is x. I am just applying some mathematics. Okay, so O to A is x, and I have divided this into small segment so that I can integrate it. Okay, what is integration? Is basically an area under curve. Okay, but अगर आपके पास इतने x एलिमेंट है, इतना बड़ा, ओके, 0 to x तक है, तो आप इसको क्या कर सकते हैं, छोटे dx एलिमेंट्स में डिवाइड कर दो and integrate dx from 0 to x and you will get x. Okay, so that is what I am doing. I am actually taking this as x and I am dividing dx small till O. Okay, so I can find out because I have a distance x and I can find out force at A. Okay, force at A. So force at A basically is F naught, which is basically, this is F naught only na. F naught is basically K, the product of charges divided by the distance square. So this charge multiplied by this charge divided by x square. So K times Q naught Q divided by the distance square. So this is your force F naught. I have found out force. Oh, this is not r square, this will be x square. Okay, so everything is ready. Everything is ready and nature wants to be calculated, and if nature wants, then I can't stop. Okay, right, so I will put this equation into this. Okay, so dw I have is negative k q naught q divided by x square, k q naught q divided by x square times what is dx times dx. Okay, if this is a small work done, this is a small work done from this point to this point, this is a small work done from this point to this point, and I can generalize it to any point. Suppose I want to generalize it to P point P, I can do that, because I am taking a small element dx. This is very small because I want to show you, so therefore I have magnified it, but it is basically this way, dx 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 element and 0 to x, and you integrate it. That's as simple as that. Okay, so I can find out at P, I can find out at C, I can find out at D, I can find out at any point in this line, or in fact any point in the whole thing, because charge due to plus q is basically spherically symmetric, radially symmetric. Field lines are equal everywhere. Okay, so this I got work done, and I want to find out work done. Okay, work done from A to point B. Work done from A to B. Okay, so let me rub this thing so that I can write. I will make this diagram again. Okay, so work done is dW, so integration you will get the total work done from A to B, and you can generalize from A to P also. That's not a big thing, you can generalize it. So dW is minus k q naught q dx over x square. Okay, this integration, and I hope आपने ये सब लिख लिया होगा. And this thing is basically integral, this thing is minus 1 over x, this thing is minus 1 over x. So I got minus k q naught q, okay, minus 1 over x. Okay, so I want from which point to which point, to suppose x equals to A to B, I want to suppose A to B. So you can cut this minus and minus sign and just put because integral is 1 upon b minus 1 upon a, integration will be, so 1 upon b minus 1 upon a. Okay, so this negative sign will not be there. Okay, and from this derivation I can derive both the thing and I can explain you both the thing. So from A to B this is work done. Okay, so I got work done W is equals to k q naught q 1 upon b minus 1 upon a. Okay, and if I divide the whole equation by q naught, the whole equation by q naught, then I get W over q naught is equals to q naught cancel, kq, this multiply by b minus kq divided by a, and kq divided by b is a distance from O to this thing, so b is a distance and a is also a distance, and this is called potential at point B and this is called potential at point A. So this is denoted as VB and this is denoted as VA, and this is called work done per unit charge, and this is called potential difference. Okay, this is called the potential difference. So from work done against a plus charge, that source charge, by q naught from A to B against the Coulomb force is basically stored as what is called potential energy, and you can say that there is a difference in potential is work done over a charge q naught. So work done on charge q naught is difference in the potential from potential this to this, that is called potential difference. And what is potential? Okay, and you can generalize it for other point also. Okay, what is potential? So in the same derivation, if I put A, suppose it was at like this, it is plus q, it was at O and from A to B. Okay, so one question arises, why it is VB minus VA, why not VA minus VB? So it is very important, always remember that potential is always from higher to lower, not lower to higher, and also it is dependent on the distance, therefore If distance is less, potential is high. So this is a less distance, that means it has a higher potential. This is distance is more, it is lower potential. Higher potential, lower potential. That is why higher minus lower potential. Okay. Now suppose I want to derive what is called potential. This is potential difference. So this is potential difference of basically electric charge, you can say, or you can say electrostatics, potential difference in electrostatics. And what is potential? So suppose you have this point, and earlier you have traveled from A to B, from Q naught A to B. If I बट इन जनरल डेरिवेशन के लिए आपको ये करना पड़ेगा कि हमेशा इस A से B तक पॉइंट नहीं रहेगा, हमेशा A से B इतना छोटा पॉइंट नहीं रहेगा. देयर माइट बी अ केस जी चार्ज आपके आसपास ही नहीं है सराउंडिंग के, तो आप ऐसा अज्यूम करेंगे कि दूसरा चार्ज जो है वो इन्फिनिटी पे. तो इन जनरल अगर मैं कुछ करना चाहता हूँ कि सपोज करता हूँ कि मैं इन्फिनिटी से चार्ज लेके आया Q नॉट एंड कहाँ तक गया, B तक, इन्फिनिटी टू B. Then tell me the potential. पहले क्या था, A to B, then tell me the potential difference. And I am asking if it is from infinity, बहुत दूर रहता अगर चार्ज, वहां से आप A B पे लेके आते तो क्या होता potential difference. Suppose B is B and A is at infinity. So A is at infinity. A point is at infinity. Earlier the A point was here, and now the A point is at some infinity. So I will put just A is equals to infinity in this equation. So I will get W over Q naught is equals to KQ by B minus KQ by infinity. So at infinity, what is 1 upon infinity? Mathematics tells that it is 0. And what is the physical interpretation of this? आप ऐसे कट कर रहे हैं physics mathematics में, that's okay, but you are studying physics. तो बेसिकली क्या है कि अगर यहाँ पे एक प्लस क्यू चार्ज है, उनका पोटेंशियल मैं किसी इन्फिनिटी पे पता करना चाह रहा हूँ, वो जीरो होता है. इसका मतलब ये है वहाँ पे इन्फ्लुएंस नहीं रहता उस फील्ड का, उसका इन्फ्लुएंस नहीं रहता है एट इन्फिनिटी. दैट इज व्हाई इट इज जीरो फिजिक्स से. ओके, बिकॉज फिजिक्स इज बेस्ड ऑन लॉज एंड प्रिंसिपल. यू कांट से दैट बाय डेफिनेशन एंड ऑल. मैथमेटिक्स में आप बाय डेफिनेशन प्रूफ कर सकते हैं, बट इफ यू आर कटिंग समथिंग यू जस्ट कांट से दैट 1 upon infinity is 0. दैट इज व्हाई यू आर डूइंग दैट. Maybe there can be other thing, there can be experimental data that infinity पे भी हो सकता है potential. तब आप क्या कहेंगे, तब मैथमेटिक्स गड़बड़ हो गया. So basically physics works on laws and principle. क्या चल रहा है, that statement you have to give. I can't just say that कि मैथमेटिक्स में ऐसा होता है इसलिए. I have to give physical significance also. So that is the physical significance, that at infinity we have found out that the potential was not there. So the influence of that plus Q charge was not there. So what is W over Q naught? Is KQ by B, and this is what is called potential. This is potential. Oh, okay, this is potential. So generally they will ask that at distance r, potential, find out potential at distance r. So you just have to assume that this distance was r and just replace B by r. In general I am talking, okay, just replace B by r and that's it. एंड समटाइम ये A और B नहीं रहता है, कभी R1 और R2 रहता है. तो यू कैन एक्चुअली डू दैट कि ओके B मैंने, दैट्स ऑल्सो ओके, ठीक है, चलेगा. सो दिस इज बेसिकली W अपॉन R1 माइनस R2 भी आप कर सकते हैं, दैट डिपेंड्स ऑन यू. सो दिस इज बेसिकली अ पोटेंशियल एंड दिस इज पोटेंशियल डिफरेंस. ओके, तो What is the basic difference between potential and potential difference? Derivation तो हो गया है, अब basic difference पता करते हैं. See, मैं ये कहूँगा कि सबसे important चीज़ potential नहीं, सबसे important चीज़ potential difference है. I will give you a reason for that. I have found out that work done on any charge Q, I don't know which charge it is. अगर Q नॉट की जगह some Q3 रहता है, Q4 रहता है, any charge जिसको आप अगेंस्ट किसी फील्ड के अगेंस्ट चला रहे हो, you are actually basically picking a charge Q naught and you are moving against a plus Q or a field, is change in potential, is basically change in potential. And what is change in potential is, you can say that V at any point which is high minus V at any point which is low. Okay, higher to lower. This is the basic thing, and this is called potential difference. And what is potential? If V low is 0 and L is equals to infinity, then we say that W over Q is equals to V high, and this is potential at point H. So that is the difference between potential and potential difference. Now डायग्राम से हम बताते हैं क्या डिफरेंस. ये तो फॉर्मूला वाइज हो गया, बिकॉज इसमें बहुत प्रॉब्लम होती है लोगों को, तो सॉल्व कर देते हैं. तो डायग्रामेटिकली क्या कह सकते हैं, अगर ये प्लस आपके पास एक जनरल चार्ज प्लस क्यू है एंड इसकी फील्ड है खूब सारी, एंड ये पॉइंट से ये पॉइंट ए टू बी अगर आप वर्क करा रहे हो, दैट इज पोटेंशियल डिफरेंस. बट इस ए पॉइंट को आप उठा के इन्फिनिटी पे ले जाओ, इस ई पॉइंट को हटा के यहाँ पे ए चला जाए इन्फिनिटी पे, देन वी से दैट इट इज पोटेंशियल. एंड दैट इज द वेरी डिफरेंस बिटवीन पोटेंशियल एंड डिफरेंस. तो आई होप आपको ये अच्छा लगा होगा. डू सब्सक्राइब इट एंड शेयर दिस वीडियो. थैंक यू सो मच.